Part number 3 here. We already have a Carroll Middle world record for number of podcasts for a quiz or test. Okay. Difference between crystalline and amorphous solids. First of all, crystalline, appropriate name, made up of crystals. Examples, salt, sugar, and snow. Hopefully we've got a storm brewing up here. Love to have a white Christmas. Amorphous are not arranged in a regular pattern. These do not melt at a distinct temperature. They're more or less going to become, they're not going to completely go from like a crystalline where they're going to evaporate. They're going to melt. They're going to become more of a liquid. So you think of glass, you watch someone create some sort of artwork or a vase or anything with glass, that actually melts down. They can form that, and then when it gets back to a temperature, it will solidify again back similar to how it was when it started. Okay, viscosity, we've kind of looked at this a little bit, but let's talk a little more detail. It depends on the size and shape of its particles and the attraction between these particles. Stronger the attraction, slower it moves. Weaker the attraction, of course, the faster it moves. Honey has high viscosity, water's going to have low. Okay, know all the changes of state and what they go between. All right, if we go from a liquid to a solid, that's going to be freezing. Gas to a liquid is going to be condensation. Solid to a liquid is going to be melting. Solid straight through liquid to a gas is going to be sublimation. And liquid to gas is going to be vaporization. All right, continuing here with Chapter 4, we have Charles's Law and Boyle's Law. Charles' Law states that when the temperature of a gas at constant pressure is increased, its volume increases. So if one increases, the other increases. If one decreases, the other decreases with Charles. So as we look here at our graphic, if the temperature decreases, so we've got cold here, then the volume drops. And if the temperature increases, as you can see, this volume increases. So when one increases, the other increases. When one decreases, the other decreases. So now as we look at Boyle's, now these are basically opposites. One increases, the other decreases. So as we look here, if we increase the pressure, so we push down on this volume decreases. The amount of space available decreases. But if we decrease the pressure here, pull this knob up, the volume increases. The amount of space inside gets higher. Understand how the individual molecules behave in all the states of matter. Talked about this a little bit earlier. Now we're talking about individual. Solid are going to vibrate in place. Liquid's going to slide around but still touch. And gas is going to spread apart to fill a container. Okay, Chapter 5 here. This should hopefully be fairly familiar, as we just took this quiz on Wednesday. First of all, let's start with what is energy. A lot of you have a great handle on this, looking at Edmodo, Moodle, and even questions from the quiz. That's an ability to do work or cause change. Okay, how to calculate power. That's going to be energy transferred divided by, that's a divided by sign, time. And then let's even talk, we got a lot of math here, formula, and how to calculate kinetic energy. Well, kinetic energy is going to be 1/2 times the mass times the speed squared. So let's look at a couple of these here. A girl and her dog are running. The dog has a mass of 20 kilograms. The girl has a mass of 60 kilograms. So we're going to do some calculations here. Suppose both the dog and the girl run at a speed of 2 meters per second. Calculate both of their kinetic energies. Okay, pause it right now. You do the math first. Don't cheat. In fact, this is a great spot to stop the podcast. So before you start the next part, do the math. Figure it out. Then start the next podcast. See you in a couple minutes.